Change it up. Today's supposed to be hot as hell, so.
Yeah, it's supposed to be warm today.
So I want to dress appropriately. So last time we made it through 7-1. Any questions from homework?
Oh, yeah.
Number 66.
Where?
7-1. And number 66 and number 72 actually.
66 is this guy here, right?
It's our third one.
7.2.
John, this guy here?
Yeah, that's it. No, 72, not 7.2.
So don't let the fractions bother you. What's the property when you divide like bases? What do you do with the powers? Subtract. They're fractions, but the really nice thing about those fractions is that they already have LCD. So the property, like you told me, was you take 2/7.
Subtract it from 5/7. So you'd have -3.
Well, it makes it
3/7. Negative 3.
Negative
-3/7.
3/7. So it'd be 1 over x to the 3/7.
I like it. Flip the x. So now it's 1 over x to the 3/7. The biggest mistake is people make it 7/3. But then you're trying to tell me that -3/7 equals 7/3. That would be interesting. We know that a negative power makes the thing being raised to the power flip. So be careful. Don't think flip, flip, flip. Oh, flip, yay. No. What's being raised to a negative power? The x. That's what gets flipped. Right? -3/7 does not equal 7/3. Negative numbers don't flip. Negative powers make the base flip. Things can never change in math. I wish this was true. Make all my debt become not debt. That'd be great.
But now that they owe me
But the
$10.
bank won't buy it. I've tried it. So you can trust me, I'm a math guy.
Could you do 51 and 63?
In the same section?
Yeah.
And then 76 too, please.
Number 7.
In the next few minutes, I'll just do all the homework. Yeah. All right, you guys.
73, 76.
And well, tell me how far you got. So what did you do first year? You didn't know well.
Isn't that what I did?
You went over 3, 3, 3.
I went over the
4 threes. She named 27.
Okay, I like it. But it's a negative power.
69. I need it to be 62. That's right.
It's a negative power, which means
Flip it.
It was
Flip.
72.
so the first thing you really should do is
Oh, well.
flip the 81,
I got something different there.
and then you'll be golden, right? Then everything you just said is perfect. It's just that it's a negative power. It's got to flip.
So it becomes 1 over 27.
Beautiful. If 81 to the 3/4 is 27, 81 to the -3/4 is 1/27. That's all a negative power does, is just put 1 over what it would normally be. Now let me catch everybody else up, because it sounds like you like that shortcut approach I showed last time, which is awesome. But not everybody likes the same thing. So let's say everybody's cool with that negative power. That's the first thing I take care of. Get it out of the way. What's the root here? What's the fourth root of 81 to the? Now what is 81 made up of? 4 of them multiplying. 3s. 3 times 3 times 3 times 3. And if you're not sure, just start to break it down. 81 is 9 times 9. And then 9 is 3 times 3. So you do end up with 3, 3, 3, 3. So you know that the fourth root of 81 must be 3. Because the question that a root asks is, what does it take this many of to multiply to be this?
So 4 of whatever number has to equal 81.
Yeah, so it takes 4 3s. So the fourth root of 81 must be 3. And then, of course, 3 cubed
Is 9. 27, I'm sorry. That's square.
And again, I mean, I don't care what the topic is, really. The thing that makes it so much easier is just take it one step at a time. There are always people that want to shoot to the answer, and that would be great if you could. The homework would fly by. But it's one thing if it flies by and you're getting every damn thing wrong. That doesn't really mean it's flying by. You got to redo it. So what good is that? Take it one thing at I know a negative power means flip. I don't care what the hell else is going on. Negative power means flip. Okay, now I go, okay, crap, what do you say? Okay, what's on the bottom? Roots are on the bottom of things. Roots are on the bottom of plants, right? So it's a fourth root of 81, and the top is the power. Then you focus your attention on this. How the hell do I do this? Well, how if I try to break 81 up into 4 parts? All right, let me start breaking it up and see what it's made of 4 things worth. Right, sure enough, it's 4 threes that make 81. So the answer there must be 3. And that part I really want you guys to understand. That's what every single root is. That's why the answer to square root of 49 is because it takes 2, understood 2 7s to multiply by 49. So what's the cube root of 64? 4, because it takes 3 4s to multiply by 64. So you can always kind of check your work. The 3 of these multiply to be this, check. So 4th root of 81, it takes 4 3s to make 81 multiply, right? So that's what the 4th root of 81 is. Cool.
I have another solution, but I got the same.
Oh, so you did it in a different order?
Yes.
You flipped at the end, maybe?
Yes, 81 power 1/4 between brackets.
I love it.
Minus 3.
I like it. Beautiful. There are different ways to do this. I love it.
Oh, this phone 66. Can't I go shortcut to get the answer? Because I don't subtract.
Oh, well, to me, yeah, I'd say 2 7s cancel. There's 3 7s left on the
I
bottom.
go direct.
I like it. Okay.
Shortcut.
All right, all right.
Number
Oh,
63.
oh, good. That's the one I expect. Question.
Well, number 60.
Yeah.
Well, that was easy. You just multiplied the powers.
Are they like terms?
Yes.
Yeah.
Are they like terms?
No.
They are.
No.
I got a 49 and negative 1/2, and you're trying to add it to a 25 and negative 1/2. It's not like terms. It's like x plus y. I can't add those.
Your exponents are like terms, though, so you can
Who
work on
cares? Hey, look here. X squared plus y squared. Can I do anything with that?
those. You're stuck there.
Because these aren't the same, are they?
You have to
They
multiply.
are not like terms. But what is 49 to negative 1/2? What's a negative mean?
Flip it.
Flip it
It's 1/7,
to
basically.
the 1/2, right?
1/2.
And the same thing here.
25.
1.
1 over 25 to the 1/2,
Yeah.
right?
So basically, you're left with
And
1/7.
the 1/2 power is a what root?
Square root.
What's the square root of 49?
7, so it's 1/7 plus
7.
1/5.
What's the square root of 25?
1/5.
And now I think you can finish it out.
You can.
That's a really easy problem to make a mistake on because we just, our brain says, oh, just add the damn things. And our brain says, oh, look, they're the same. No. Just the same, like I showed you, you can't add these. And the same reason that's why you can't add these is the reason why you can't add those. They're not like terms.
You have to have.
Now, if I had
Because
x to the negative 1/2 plus x to the negative 1/2, what do you guys think that would be? Careful.
It'd be.
What's x plus x?
X.
What's x plus x? 2x. What's this plus this? 2
2x.
of these.
2x.
Which you could then make 2 over, let me see if I can do that. That would flip, right? And this is square root.
No.
These are like terms now.
Yeah.
No.
You'd still have x to the 1/2 power.
Is that how it is? No, that's not the
What happens? The 2 is fine. It stays. The x to the 1/2 goes in the bottom. And a 1/2 power is a square root. Right?
Right.
But the main thing I want you to get from this is these are like terms. Everything's the same, so I'm allowed to put them together. Right? It's the same variable and the same powers. They are like terms. Here, in one sense, these are not the same variable, right? They're not the same base. I can't put those together. I've got to take each one separately.
I got confused right there. So when you do flipping that one, the 2x, that, so you leave the whole number. You don't change the whole.
In
number?
this case, I leave the whole number because I only flip things that are raised to a. No, I only flip things that are raised to a
Negative
negative
power.
power. What's the 2 being raised to?
A
and
negative,
understood 1.
yeah, so it's
Not a
still,
negative
That's
power.
right, that's right.
The X.
Be careful, this negative 1/2 is not that powerful. It can't say, I come to you too. No,
Yeah, I know.
right? It's only on that X.
Okay.
So that's a major mistake. You know, way back when we just had negative powers, no fractions in them, I always saw people doing this. I didn't understand why people do that. In fact, that's the mistake I can live with to a point, because at least you know that that means flip. But it should mean flip the thing that's being raised to a power. The 2 is this should not. The 2 should stay.
Yeah, totally.
This goes down.
that's still taking off some points then, if somebody does that.
This is what I'm confused about. Why does it become 2x? Like I get you add the x's, but what if it was like 25 negative half plus 25 negative half?
Okay.
Can you add them?
If it was 25 negative 1/2 plus 25 negative 1/2, it would be 2 25 negative 1/2.
So
You have to make
1
5,
over 35.
1 over.
That's all, just like the 2 these to negative 1/2. You'd still have to simplify this. Could I multiply 2 times 25 first? Because what's order operations say? Exponents comes before multiplication. Order operations will save your ass so many times. You think that we've gone away from that chapter. The chapter that order operations is every damn chapter in the book. Order operations is always there, right? So here I have to raise this to this power before I can multiply. So let's look at that one real quick.
Exponents comes before multiplication.
Powers.
If I had this, right? If I had that, I could put those together.
50.
Now what's 25 to the negative 1/2?
1 over,
It flips,
or 2 over 25 to the 1/2 power.
45 over 5.
which is 1 over square root of 25, right?
So it's
1/2 power is a square root.
1 over 5.
2 over 1 times 1/5.
Right.
Wait a minute.
Fifths, right?
Oh wait, okay,
Sure.
I see.
Okay.
Yeah,
The 2 would stay up top, because it's not being raised to any power, let alone a negative power. So the 2 is fine where it is. It's the 25 that goes down and then gets square rooted to become a 5.
Perhaps
the base the same, and the powers we multiply the powers. When is this case? The base the same.
And the bases don't have to be the same. I mean, of
Like
course,
this.
if I have this, what am I going to do with the powers?
Here we are.
You're gonna
If
multiply.
I have this, what are you going to do with the powers?
You multiply the
Okay.
parentheses.
7 over 1.
So here I'll need LCD.
Yeah.
Here, what's the answer?
It's 7 over 4.
Okay.
Right? I just multiply. When I multiply, I don't need an LCD. It's only when I add that I need like terms. I need LCD-like denominators, like terms.
Now here's a question for you. If you have a number that's raised to a fraction of a power, does that mean you've multiplied that number by a fraction of itself?
In a
Like if you
way,
have 25
Let's not go down that road.
Alright.
But basically, if it's a raised to a fractional power, you have less than that number, right? I mean, 2 to a first power is a whole 2. 2 to the 1/2 power is 1/2 of a 2 somehow. It's the square root of 2.
So you multiply by
So a
1.
fractional power, sure enough, does cut it down. As long as that fraction is less than 1, right? It makes it less than a whole 2.
Okay, I was just curious.
That's less than a whole 2.
Okay.
Cool.
I'm just curious about that.
Does that make sense to you? I mean,
Yeah.
This solution. It isn't x the power 4 plus 3/7.
yeah, so this top one would be x to the 1/4 plus 3/7.
LCD.
So like you guys said, we need an LCD.
28.
It will not.
28.
Multiply by
Then you
7
just make
and
an
4.
LCD and put
Yeah.
them together, right?
It will not be the same answer.
All right, so let me rein this in a little bit. We're jumping all over the place.
Oh,
So the main thing to get from that section is that none of the properties of exponents have changed at all. We're just going, what if I put some fractions up there? Okay, you just deal with the fractions. You still add them at the right time, subtract them if you divide, multiply if you raise them. You just start multiplying and adding fractions. It's the only new thing. So it's nothing new, it's just that we're throwing fractions in there. Yeah.
Did you want us, like on number 72, did you want us just to do multiplication of both A and B, top on bottom?
We can't. I mean, you can't put these together, right? There's nothing you can do between there.
Well, I multiplied top